This video is going to be all about my pick for the most practical and biocompatible kitchen countertop material. If we haven't met, I'm Veronica London, founder of Homebody Home. I hold a master's degree in interior architecture with a specialty in creating homes that are as supportive to the body as they are beautiful. I evaluate materials beyond aesthetics, examining how every aspect of our built environment interfaces with the health of our bodies. On this channel, we go deep, exploring furnishings, layout, building materials, light, air, water, and electric fields, so we can create nourishing, harmonious, and vital interiors. So let's get into it. For kitchen counters specifically, I'm optimizing for the following 4 considerations: low maintenance, inertness, beauty, and durability. And today we're talking about the materials that currently rank at the top of my stack. They're very similar, but they're not exactly the same. And what I'm talking about here is sintered stone and porcelain slabs. Well, let's unpack this properly. We'll start with sintered stone. Sintered stone is essentially engineered rock made without using glue. It's made from powdered natural minerals, quartz, feldspar, silica, clays, compressed under enormous pressure and fired at very high temperatures exceeding 1200 degrees Celsius. There is no resin binder. Instead, the mineral particles partially melt at their surface and fuse together at a molecular level. It's closer to how stone forms in nature, but very accelerated. Now let's talk color and pattern, because this is where people assume something chemical must be happening. Most sintered stone is colored using inorganic mineral pigments. Things like iron oxide for reds and browns, manganese for grays, cobalt for blue, and titanium oxide for whites. These are ceramic grade mineral oxides. They're mixed into powdered mineral blend before pressing and firing. That means the color becomes part of the slab itself, not just something that sits on the surface. For veining and marbled looks, manufacturers use one of 2 methods: layering different colored mineral powders before compression, so the pattern runs through the body, or applying ceramic-based digital inks to the surface, then firing again so the design vitrifies into the slab. The important thing is that these inks are mineral-based and fired. They're not plastic paint sitting on top of your counter. And typically, sintered stone does not require topical sealants. The firing process vitrifies the surface, making it extremely dense and non-porous on its own. If you ever see something like nano coating or protective layer in the marketing language for these materials, that's worth asking about. But for the most part, brands rely on the material density itself rather than applied sealers. So structurally and chemically, it's a fused mineral slab. Now, what's porcelain slab? So porcelain slab is technically a ceramic. It's primarily clay, feldspar, and silica fired at very high temperatures. In North America, porcelain is defined by water absorption of 0.5% or less, and that's why it's so low maintenance. Large format porcelain slabs are essentially porcelain tile scaled up to countertop size. Coloring works similarly to sintered stone. It's mixed with the base material and mineral pigments, again, usually inorganic oxides, before firing. For patterns, especially things like marble or stone looks, porcelain slabs often use high-resolution digital ceramic printing. The design is applied using ceramic inks and then fired, so the pattern becomes part of the vitrified surface. Higher-end slabs may also use layered coloration techniques, but porcelain more commonly relies on surface printing for dramatic veining. And again, because it's vitrified ceramic, it typically does not require sealants. The density and firing process create a low absorption surface. No resin binders, no polymer top coats in most cases, just fired mineral material. So what's the real difference? It's really not very different, to be honest. Porcelain is clay-based ceramic, so it doesn't have like as many mineral compounds. It's defined by very low water absorption, and it's a long-standing material category. This is not a new category, whereas sintered stone is broader mineral blend, often higher compression, marketed as ultra compact surface, which is also very low absorption, and sometimes has more full body patterning options. I would say in my experience, it can look a little more rich, a little less sterile than ceramic can sometimes look. They perform very similarly. The differences are more about formulation and branding rather than the practicalities of daily function. Now let's run them through my criteria for selecting countertop materials. So the first criteria is low maintenance. So what do I mean by low maintenance? I'm thinking non-porous, no sealing required, resistant to staining, acid resistant, no lemon etching drama, doesn't show every micro scratch. Both materials excel here. Their low water absorption rates make them extremely forgiving in real kitchens. No annual sealing schedule, no marble anxiety, no, oh, I left turmeric overnight or spilled wine. They are designed to be used. The second criteria is inert. So low emissions, low shedding. So let's look at emissions first. Both materials are resin-free. They don't rely on polymer binders that can off-gas, so that's great. If you want extra reassurance, you can look for UL Green Guard Gold certification for VOC emissions specifically. The second criteria here is shedding. In normal use, most countertop materials don't meaningfully shed particles. But the bigger particular concern is that there's fabrication dust, right? And if this fabrication dust contains high levels of silica, as it does, for example, in engineered quartz, it can create major health issues for people involved in fabricating and working with this material. So while it won't impact you so much in your home after installation, it's harmful enough that actually engineered quartz has been banned in Australia since 2024 because of risks to worker health. Sintered stone and porcelain slabs do not fall under this ban, though, of course, proper precautions are necessary when cutting any silica-containing materials, but the silica in these materials is not a very high percentage. Once installed, sintered stone and porcelain slabs are stable mineral surfaces. The third criteria is beauty. This is where design people get emotional. I'm not a big fan of faking materials in general, but of course these materials do come in different looks. You can get the Calicut marble vibe, concrete, limestone, or just solid mineral tones, which would be my personal preference. Some slabs are full body color, some are surface printed marble effects. Higher end options have depth and nuance. Lower end options can look a little flat in certain lighting. Things I look for are, does it look plasticky in raking light? How visible would the seams be? Does the finish show fingerprints? Does it feel sterile or grounded? Honed finishes tend to feel warmer. And let's be real for a second, as a designer, no part of me actually buys into the beauty is in the eye of the beholder narrative. So in other words, go with the honed finish. Moving on. Durability. Durability is basically a set of failure modes. So we have scratch resistance, heat resistance, UV stability. All of these are excellent. Chip resistance is strong but brittle. We'll get back to that in a second. And repairability. Chips are possible and the repairs are not invisible. So you might see a little seam if you ever have to repair your countertop. You can put a hot pan down, you can have big sunny windows though, but edge detailing in installation matters a lot. And then just a quick hygiene reality check. If you want a sanitation North Star, NSF ANSI 51 is the commercial food equipment benchmark. So not every residential slab carries it, but it's a helpful filter if you're trying to stay grounded in real standards instead of marketing language. So why is this my top practical and biocompatible pick. Because when I scored it, porosity was very low, VOC risk very low, no sealants are used, heat tolerance is high, daily wear is forgiving, UV stability is excellent. The only real downside is that it can be less forgiving at the edges on the corners. It's basically higher chipping risk. And it is install dependent. If you choose it, choose your fabricator or installer like you're hiring a surgeon. Also, nothing compares with the beauty created by nature. Thus, of course, using natural stone will win out on the beauty front every time. But for all the reasons mentioned in this video, sintered stone and porcelain are my top practical and biocompatible countertop picks. Subscribe for my take on all the other usual suspects used for kitchen countertops and many other topics in the realm of biocompatible interior design.